Hi, this is Mr. Bledsoe, and I got a question from someone who watched my partitioning a segment video and had a question about a similar problem that they wanted some help with. So let's take a look at this problem. It says, given 2 points A and B, find the coordinates of point C that sits 3/8 of the way along AB, closer to A than to B. So this is definitely a partitioning a segment problem, and you would go about solving this problem the same way that I did in the video, although as we're going to see, there is one kind of tricky part to this problem, and let's see if you can spot it. So this says points A and B. Point A is 3, -5, and point B is 19, -1. So I'm going to set this problem up the same way that I did with the other problem in my video. The point C is somewhere along in here. It says 3/8 of the way along AB, closer to A than C. I don't know what the coordinates of point C are. That's what I'm trying to find, so I'll just call those coordinates X and Y. And I can set up my X distances and my Y distances so that I can set up proportions to solve for X and Y, again, just like I did in the original video. The thing that's tricky about this problem is that if you'll look at the original video, you'll notice that the way the problem is stated, it says to find the coordinates of point C such that it divides the segment into a given ratio. I think the ratio in that original video was 3:2. So it gives you a ratio. This one, notice, it doesn't actually give you a ratio. It says find the coordinates of a point C that sits 3/8 of the way along AB, closer to A than to B. Well, it's tempting to say, well, doesn't that just mean that my ratio is going to be 3:8? And in fact, no, that's not correct. Your ratio is not going to be 3:8. Your ratio is going to be 3:5. And the reason it's going to be 3:5 is because if this distance here, for example, if this distance is 3/8 of the way along AB, well, then this distance must be 5/8 of the way. In other words, if I'm dividing up my distance into eighths, and I want this first one to be 3/8, well, 3/8 would be the first distance, 5/8 would be the second distance from C to B, which means my ratio is not 3:8, it's 3:5. That's a very tricky and not immediately obvious part of this problem, and if you didn't spot that right away, don't feel bad because I didn't either. Well, now that I know what my ratio, the ratio of the lengths of these two segments is going to be, now that I know that ratio is going to be 3:5 and not 3:8, well, now I'm all set to solve the problem. So I'm going to find my X distances just like I did in my previous problem. So this X distance from A to C is going to be X minus 3. The X distance from C to B is going to be 19 minus X. And let's go ahead and do the Y distances. The Y distance from A to C is going to be Y minus -5, or just write that as Y plus 5. And then my Y distance from C to B is going to be -1 minus Y. So now I have everything I need to set up my proportions and solve my problem. So let's see. To find my X, I'll set up the proportion for my X distance first. So let's see. X minus 3 to 19 minus X is going to be 3:5. So there's that first proportion. And I also need to set up my Y proportion. So let's see, that's going to be Y plus 5 over -1 minus Y equals 3:5. Okay, well now I have two proportions, so all I need to do is solve these two proportions. So let's cross multiply. That's going to give me 5x minus 15, and 3 times 19 is 57 minus 3x. And let's see, add 3x to both sides, give me 8x. Add 15 to both sides gives me 72. Well, that makes that easy. So x then is going to be 9. There's my x coordinate for my point C. Let's cross multiply over here. 5y plus 25 equals -3 minus 3y. And let's see, add 3y to both sides gives me 8y here. Subtract 25 from both sides gives me -28 here. And if I divide both sides by 8, then I get y equals -28 over 8, which will reduce to let's see, 4 goes into 8, that, and 4 goes, so -7 over 2. So there's my y coordinates. So the coordinates of my point C are going to be 9, -7/2.